Let's look at some multi-step equation examples. So we've got 9x plus 1 minus 7 minus 5 equals negative 20. So the first step we've got is to distribute. We don't have anything to distribute, so we can move on to the next one. Do we have any like terms to combine? It looks like it. So let's go through the same process we were. We've got this 9x. Do we have any other x's? Look, we do. We have negative 7x. Remember that negative sign, that minus sign travels with it. So we really have 9x minus 7x, which ends up leaving me with 2x. Now we have a constant of positive 1 and a constant of negative 5. 1 minus 5 gives me negative 4. And then on this other side of the equal sign, we just got a negative 20. All right, now I can move on to the third step. I can go ahead and solve, and this is just going back to my two-step equation rules. So I'm going to undo first subtraction or addition, and this time we've got subtraction. And I undo it by doing the opposite of it, addition. Remember, whatever I do on one side, I gotta do on the other. All right, nothing happened to this 2x, so it's still a 2x. This negative 4 plus 4 cancels out. We got negative 20 plus 4. It's going to give me a negative 16. Okay. Now I can handle this this 2 being multiplied by doing the opposite and dividing both sides by 2. This gets rid of that. Negative 16 divided by 2 is a negative 8. So in this equation, x equals negative 8. So in order for this big, long equation to be true, x has to be negative 8. All right, another example. 91 equals negative 7, open parentheses, 3a minus 1, close parentheses. So this example, we do need to come up to our first step, distribute, and we do need to distribute that negative 7 first. If you don't do that first, nothing you do after will be correct. So remember to distribute. I'm going to take that negative 7 and I'm going to multiply it by that 3a. Negative 7 times 3 is negative 21. And remember that variable stays there. Please do not drop your variable. And then I'm going to take that negative 7 and I'm going to multiply it by that negative 1. Negative 7 times negative 1 is a positive 7. Okay, and this side just has that equal 91. Now, do I need to combine any like terms? No, we are good to go and to move on to solving. So I can draw my wall and handle my adding 7 over here. I'm going to do the opposite, remember, of subtracting 7 from both sides. 91 minus 7 gives me 84. Nothing happened to that negative 21a. Positive 7 minus 7 cancels out. All right, now I can handle this multiplication here by dividing both sides by negative 21. 84 divided by negative 21 ends up being negative 4. Negative 21 divided by negative 21 just leaves me with a. So in order for this equation to be true, a has to be negative 4. All right, let's look at this third example. We got 11x minus 2x minus 1 equals 118. Do we need to distribute like our first step says to? Well, we don't have a number outside this parentheses, but we do have this negative sign. Remember, this is an understood 1. So I do need to distribute my -1 to everything inside my parentheses. So I'm going to take -1 times 2x. So that gives me -2x. And then I'm going to take -1 times -1, and that gives me +1. All right, up here we've got this 11x, and over here we've got 118. All right, our next step, combine like terms. Do we need to combine any like terms? We do. So we've got this 11x, and then we have another x of -2. So 11 minus 2 is 9x. We have this constant of +1. We have no other constants here, so we can say positive +1 here, and on this side we just have 118. Remember, even in this step, in these steps, we're on that wall, okay? So just because we have a constant of 1 here and we have got a constant of 118 here, we can't combine those. They're on opposite sides of the equation, of the equal sign. All right, now I can go to my third step of solving. Undo the addition or subtraction. We got addition of 1, so I'm going to subtract 1 from both sides. Nothing happened to this 9x yet. +1 minus 1 is 0. 118 minus 1 is 117. All right, now I can handle that multiplication by dividing both sides, and I'm running out of room to write. So 9 divided by 9, remember this, where's my black pen? Wall here. We're still in this wall. 9 divided by 9 just leaves me with x on this side. 117 divided by 9 ends up being 13. So in this example, in order for this equation to be true, x has to be 13. Okay, one final example. We've got 2, open parentheses, k plus 6, close parentheses, minus 5 equals 11. So as you guessed it, we have to distribute first. So 2 times k is 2k. And I'm going to take 2 times 6, which is positive 12. And then I've got a minus 5 equals 11. All right, let's combine like terms. We got a 2k. Do we have any other k's? Again, we're just working on this side of the equation for now. We don't, so that's just 2k. Oops. We've got a positive 12 and a minus 5. So that is a plus 7. On this side of the equation, we just have an 11. So let's build that wall. Same steps. Let's take care of the addition first by subtracting. Nothing happened to that 2k. We got rid of that. 11 minus 7 is 4. Excuse me. Now I can handle this multiplication by dividing both sides. Again, I'm running out of room. 2 divided by 2 just leaves me with k. 4 divided by 2 is 2. So in this case, in order for this whole equation to be true, k has to be 2.